Our next speaker is a software engineer who spends her days working on Java, microservices, and all the backend tools that help put them together. After years studying finance and working in operations around the world, Heather will always have a soft spot for good old-fashioned spreadsheet, but she is currently focused on making insurance more modern, accessible, and affordable at Marshmallow in London. The title of the speech, Event Sourcing, Superpower, or Super Pain. Please welcome on stage Heather Whyte, and with her, Zeno, VP Engineering. A round of applause.
Thank you. Hello, everyone. My name is Zeno. I'll just take a few minutes to introduce our company, and then I'll hand over to Heather. So Marshmallow is one of the fastest growing insurtechs in the UK. We're focusing mostly on drivers who are new to the country, like migrants, like expats, etc. So traditional insurers have deemed these customers as too risky, and therefore they ask for a very high premium. What we do in Marshmallow is that we use like more elaborate sign-up flows, validation techniques, a lot of data, fraud models, mobile telematics. So a lot of techniques to do a better risk assessment of these customers and therefore offer very competitive prices. On top of that, we build all the core functionality that our insurance company needs to operate, like pricing, like claims management, etc. So all our technology is currently in-house. So the way we build software, we organize ourselves in multidisciplinary teams with engineers, product people, designers, data scientists, pricing analysts, whatever it takes. The teams own the whole life cycle of software development, so they define the roadmap, build it, test it, operate it, pretty much everything. On top of that, we allocate 15% of our time for every engineer to work on whatever they want. We think this is really important for innovation and quality in the long term. On the tech side, we're using Java on the back end, TypeScript, React and Redux on the front end, and native Android and iOS. We are fully on the cloud. We're using a distributed architecture with a lot of microservices, probably more than we should. There are a few learnings there that Heather will talk about. So why am I here today? We are setting up a development hub in Budapest. We are currently creating our teams for pricing and fraud. Our goal in the long term is to have parity between our London office and our Budapest office, both in terms of size, but also in terms of business critical initiatives we're working on. So yeah, we're hiring. So our booth is over there. If you have any questions, come and find me. Now I'll hand over to Heather for the interesting bit. Thank you.
Thanks, Zeno. Hello. So as Zeno mentioned, my name is Heather Whyte. I'm a back-end engineer at Marshmallow. Originally, I'm from Canada. Currently, I'm working in our London office, but I'm here very excited to be at Budapest Craft Conference to talk to you guys about event sourcing. So more specifically, this is a chance for me to talk about my constant love-hate battle with event sourcing, and to talk about what are some of the things that really get me excited about it and also make me really just want to smash my head into my keyboard. It's a bit of both, bit of a balance. So today I'm going to start off just by talking about what is event sourcing. Just for out of curiosity, does anyone here currently work with event sourcing? Has anyone kind of heard of it but not really used it? Or is this the first time someone's hearing about event sourcing? Okay, a couple of you. Okay, we got a full spectrum, but regardless, this is a good chance for us to get together, sort of align on the same terminology, get a little bit of sense of what it is I'm going to talk about. Then we get to the fun stuff. We're kind of talk about the good and evil side of event sourcing. And if by the end of that, I haven't completely put you off the thought of using event sourcing, how you can use the good features of it in order to get something really interesting out of it if you decide to use event sourcing yourself. So the reason I wanted to talk about this is Marshmallow, over the past 5 years, we've been using event sourcing. We're only about 5 years old as a company, so literally from the beginning. We've been using event sourcing for some of our very core domain areas, including insurance policies. And so over that time, we've changed a lot as a company to where we are now, but it's been really interesting to sort of get an experience of seeing how it worked, where it's been really helpful, and what are some of the lessons learned that hopefully, you guys can learn from some of our mistakes. So let's get started on what is event sourcing. I've used the phrase enough already, so if you're one of those people who hadn't heard of it before, my apologies. But in summary, event sourcing is capturing all changes to an application state as a sequence of events. It's a software architectural pattern that you use in order to save, view, and handle your data. And it's one that is getting a little bit of a renaissance right now, I feel. It's sort of like having a moment where it's much more popular. You'll read about it in blogs, see it in conference talks like this one. But it's actually quite an old idea. Like this quote itself from Martin Fowler in 2005. But event sourcing was around by like other names as well, even before that. You've actually probably used event sourcing, even those of you who haven't maybe built with it before. You've definitely used systems that use event sourcing, possibly even today. Some of the key examples that are really common, banking. Like banking and an accounting ledger is one of the default go-to examples of what is event sourcing. Every time you use your card to pay for a cup of coffee or you get money deposited into your bank account, these are just a series of transactions that your bank uses to understand what has happened to your money, how much money you have or don't have, and then uses that to find out your total balance. Also, many relational databases under the hood are using event sourcing. It's just a series of transactions of inserts, updates, deletes. Also, you'll see it a lot in program actions. So sometimes you hit Control-Z, you try and undo your action, say you're in a photo editing software. It doesn't just revert to the previous state. In your undo, it will say undo resize image or undo color, and you can redo that because it's not just memorized states, it's seeing what actions you've done to this image and allowing you to move through that. It's also used in healthcare when you're looking at how people are being treated, what their vital signs are. And of course, as I'm going to be talking about today, it's used in car insurance. Car insurance and insurance in general is actually a really good use case for event sourcing because especially for insurance, finance, anything that's a very high compliance environment, because it allows you to know a complete record of everything that's happened in your system. So next thing I just want to talk about again to sort of get us all on the same page are some of the key terms you're going to hear me using as we're talking about event sourcing. Oh, there's a clicker. Clicker does not work. So you have events. So the events are when I'm talking about event sourcing, events are immutable business actions that have happened. So these are facts. This is something that is. And a couple of the terms I kind of want to highlight. One is action. So events, good events, I like to see them, or one of the patterns we like to use is they should be actions, they should be verbs, they should be a thing that happened, not the state itself. So you want to have an increment, not the final count. Those are the things that you want to be looking for in your events. And then another key one is immutable. Once something is in your event log, it's just there. You can't change it. You can add additional events that might change how it's interpreted, but you can't go back and rewrite the past. Next term is event store. So these are sometimes called state transition databases. But what it is, it's an append-only log where the events are kept. It's where your events are stored. A little bit self-explanatory. This can be in a lot of different methods to use this. One popular one is using Kafka. You can also just save it as CSV or Parquet files, especially if you have really large volumes of data. There's specific tools you can use. I think one is even called Event Store. But we just use normally for most of our systems just a MySQL database. So that is what we use for our event store. Next, you have aggregates. So aggregate, for those of you familiar with domain-driven design, DDD, this is a term sort of stolen from there. An aggregate is like a group or a collection of related events, but that are treated as one for the purposes of data. So, for instance, if you have a bank account, you could have an account aggregate that is made up of many events related to that one account. So many different event transactions, but they're all part of one group, one aggregate. You have a stream or an event stream. So this is just the source of truth. So rather than any manipulated data, this is just all the events that relate to this specific domain object, to this aggregate. Your event stream is your always eternal source of truth. And then a projection is an interpretation of the truth. So this is a view of the underlying events. So you take the different events and then you project it either onto a schema, you can project it into a single value. If you say you want to get your account balance, you project it that way. But this is just, you can use projections in lots of different ways, but it's just how the projections are how other people or other services will interact with your event store. And then you have a snapshot. So a snapshot's an optional bit of the system, but it is an optimization that's really popular and really powerful, and what it does is it's exactly that. It like takes a little picture of any projection at a given time, and then that way, rather than having to replay all the events for all time, you would be able to have, I like to think of it sort of as a squashed down version, like a squashed commit, of what was happening at that point that you took the snapshot. Yeah, so these are just some of the key terms we'll be using throughout. So it's going to just walk you through now like a little example of something super fun and exciting, which is an insurance claim flow. So for those of you who have ever gotten into a car accident, hopefully not many of you, but the insurance claim process is one that is quite convoluted, it is quite large, it is quite complex, but it's something that obviously as an insurance company that we need to deal with, and it involves a lot of different parties. So for example, imagine customer has purchased their car insurance and then they get into an accident. They need to make sure that they notify their insurer that this has happened. They need to file a claim. They need to go to the garage. They need to get this validated. They might need to get a courtesy car, work with the other person's insurer, work with the regulator, possibly the police, depending on what's happened. There's lots of moving parts that are happening in sort of a complex, asynchronous environment with a lot of compliance requirements. So just to give you a little snapshot of kind of the flow that we have to go through in this. And each of these are just different things that are happening just for this basic flow of an insurance claim. So what that's going to look like in our event store, and granted, this is a very simplified version of that, but we have here sort of like a sample event store for our insurance policy aggregate. So a couple of things we've got what happened, which is our event type. In this case, the first one, it's someone purchased the policy. We've got when it happened, very, very important to know. To whom, or not, it's not always a person, it's, the general whom. But this is in our case, a policy ID, also sometimes an aggregate ID. And then literally everything else, all the other information that's key, all the context of what's going on with that policy purchase goes into this event data. We store ours just as a JSON blob, and where we're able to put information about when did they purchase, when do they want it to start, what are the details of the policy, who bought the policy, all these kind of things. Yeah, and so you can, even just with one event, you can sort of project that onto a single field. So just for our purposes, we have policy status. So this is the policy is not yet started. And then as we go through, say we get another event a couple days later, coverage begins. Something new has happened, and now when we're playing through the events, we project that into a new policy status, so an active policy. And then, oh no, something bad happens 20 days later, and there is an accident. So, as you might have noticed, with this event type, we have a new information, a new context, but this hasn't actually affected the policy status. All of events, we want to know everything that's happening, but it's not every event impacts every projection. But there was an accident, and so the customer then makes a claim, and this is now moving it forward. We have a claim submitted. But say the customer decides that, like, actually, you know what? This is just a little fender bender. It's cheaper for me to just like pay it myself rather than increasing my insurance premium. I actually don't want to make this claim. We can't go in and delete the event. That is bad. Do not do that, please. But instead, what we can do is we can add another event. So in this case, we have claim withdrawn. And you still have the full history that this has happened, but now the policy status has gone back to where it was before. So if you were just storing policy status, all you would see is active policy. And you wouldn't be able to tell the difference between like a policy as it was when the coverage began and how it is now that like it's gone through this accident and claim in, claim out, etc. So you get that full history. This is a very brief, high-level view of like what is event sourcing, and definitely there's like literal books written on this subject. But I just wanted to give you enough so that I can kind of get into the really fun part for me, which is like what my biggest like wow moments were when it came to event sourcing. It's not a fully comprehensive list of all of the pros and cons. Like, there's definitely way more to it than that, but a lot of these features I want to talk about are sort of what changed and shifted my thinking when I started to work more closely with event sourcing, to really appreciate what it could do and like how it was so powerful and why it was worth some of the pain points. So yeah, so the first superpower we've got is time travel. This is probably the one that event sourcing is most famous for. So time travel allows us to travel back to see exactly what a system looked like at any given point in time, not just what it is now. So we kind of saw that in our first example, and as I mentioned before, this is something that's very helpful for like compliance reasons. Also something that has come in extremely handy when doing debugging. So if you're ever on support, you're trying to figure out what happened, where something went wrong, being able to see what the policy looked like at the time that the thing went wrong and understanding what has changed since is something that is extremely powerful. I remember when I first started using event sourcing, previously most of my experience was working more with like classic CRUD databases, and so you just have a row and just all you'd have maybe, if you're lucky, is like an updated timestamp that does tell you when the entire row is updated, but it doesn't tell you what was updated, when was updated, how many times. And so being able to actually like look at previous events is extremely useful. It's also useful, again, as mentioned, sort of as reverting past actions. So you get to see not just like see what happened back then, but if you want to revert something that happened before, you can do it in a way that doesn't negatively impact what happened after that thing you're trying to erase, because rather than just relying again on the current state, you're replaying these things from the start. So you can literally do it in a way that like pretends this never even happened, because you're replaying you can replay the full event stream. Even if you've already made a projection or a snapshot of where it was, like the event stream is the source of truth. So you can just delete your snapshots, replay your event stream with this new source of truth, and then you can like literally revert past actions that have happened. Yeah, this last one is actually something that is a little bit new to me, which is really, really cool, that our team here in Budapest is working on, our pricing engineering team, along with our team of data scientists, and that's doing some like what if analysis. So with insurance, every year we're going to offer you a new price, and we hope that you accept it. We hope that you don't go somewhere else. But something that our data science and engineering teams have been doing is they've been looking to see at past years, looking at the data, and then applying our current pricing rules, our pricing algorithms to past data, and seeing what sort of prices would have come up, what the scenarios would have been. And the really cool thing about this is it is kind of very like multiverse system of like get to see the different threads of what might have happened had we done something differently. So it's an incredibly powerful tool that our pricing team is able to use in order to understand how can we give the best price, how is this going to impact our renewal rates, how is this going to impact the price per policy, that we're able to do using like past event sourcing data and data that we'd collected like years ago. Yeah. We also got a bonus power up when it comes to time travel. This is something that's not part of, I guess, standard event sourcing, but depending on how you build it, you can also do bitemporal event sourcing. And so bitemporal, bi meaning two, temporal meaning time. Literally, it just means that you have two timestamps rather than one timestamp. And so you have the time that the event was created, but then you also can have an effective date. So this is like a very sort of small enhancement that can give you a lot more flexibility as well. So by having a bitemporal event, you're able to put events into the future that haven't actually happened yet, that aren't yet effective. And this is like a really interesting way to have a better picture of not only where's your event right now, but what is it going to look like in the future? Like, when is this policy going to expire? When is this customer up for renewal? Without having to like calculate that every time, you can sort of set it as like projected events. Yeah. So for the next superpower, we've got X-ray vision. So not only can you like go back into time, but you can see the components that make up an application state, not just sort of the end result of what's on the surface. So you can see all these different bits and pieces, either that are part of the derived state or that would never have even been shown in the first place. So what is on the outside isn't all that there is. And this is part of the beauty of that JSON blob I was talking to you about before. Like, you can put so much information in there, and you can have so much context about what's happening with the event because you don't need to use all the information right away. One of the things when you're making, a more traditional system, you want to make sure you're thinking through, okay, what do we need right now? And you kind of want to think ahead to like where is this system going to grow? But you definitely want to be very careful to avoid over-engineering any problem. There's definitely times, everyone I'm sure has been through this, where you're like, oh, maybe we might need this in the future, and then it just becomes this like giant thing that you have to maintain, and you're just kind of stuck with, that you never touch ever again. But because of the way event sourcing works is you can have this information in there, but then in your projections, you just make the schemas that you need. So if you have additional information that you don't immediately require, then that's fine. Like, you can have it there when you're ready for it. You could add it to your schema and make your schema more complex. But if you don't need it, it's not hurting your performance in that way. So one example I like to use for how we've really gotten a good advantage of this is for our like cancellation data. So when we first started with our cancellation data, we just cared in terms of our like user interface of like, was it canceled or not? Like, that's really all we needed. We were a small, lean company. We didn't really have any other like features around that, which could have been done by a Boolean, but obviously like there's a lot of other things that might happen later, and that's exactly what happened. Later we wanted to know, okay, but when was it canceled? And so maybe, cancel that timestamp. But then, you have more questions of like, okay, but who canceled it? Like, how did they cancel? Why did they cancel? Is there like a reason that they gave? Is there any information that we have about the context of this that might help us preventing people from canceling in the next time? And because we used, rather than just having these like basic Booleans or events, or Boolean or timestamps, is be using a cancellation event. When we just needed to know, is it canceled or not, then that's all the information that we projected. And as we needed to know more information, first with debugging and then later surfacing it to our UI, then we're able to like go through and sort of improve what it is that we had, but on a sort of as needed basis, rather than having to deal with it like all the way right up front 5 years ago. Yeah. So The next superpower I want to talk about is shape-shifting. So this is definitely one of the cooler ones, but I definitely say also like potentially one of the more dangerous superpowers. The events that we have, like as I mentioned, these are like the facts that have happened. These are just the building blocks of what you have with event sourcing. What you actually end up using for your business logic to either display, for your other services to use, this is all to do with like your projections and how you're displaying the data, the story that you're telling. And the really, really cool thing about event sourcing is you can have these data schemas that are like fluid, that are dynamic, that, you know, as I mentioned with cancellations, you can like add more information as and when it's needed. And sometimes that's really, really amazing. Like, I remember my very first schema that I ever like got to design as a professional software engineer. I was designing, it was for a new microservice, so I was building in a previous company that was for property. So I was building like what is a property, like a house or an apartment, and what are all the components of that for like a mortgage loan application. And it was a relational database, had to do all my joins and stuff, and I like spent a lot of time trying to make it perfect. And then like a few weeks into using it in real life, I realized all sorts of mistakes that I made, different ways that like if I could redo it, I would do it better. But because it was like a traditional schema, it was a lot harder to sort of move and adjust now that we had production data in it. And you just sort of like, it's good enough, it's still working, it's still running, that's fine. I think it's still in production today. But when you have event sourcing, you can be a lot more like agile of like, oh, you know what, actually I kind of want to change it like this. You can do that without having to do a data migration. You can just change the way that you're applying your events, and you can change the code for your projections. In addition, like you can even take that a step further and not just change your current projections, but like events are agnostic. Like we work in like a Java microservices environment, but like the events don't have to be tied into a Java environment. Like if we wanted to spin up a microservice in Python or in Kotlin, like we could do that same with the same underlying database. You could make these changes and you still get to keep the core data that you've always had. Something that I've never had to do, luckily, but like some of my coworkers have, is doing like a full application migration. So you're able to do it where you're able to run two different systems simultaneously from the same event store, and that allows you to not just be able to sort of flip a switch going from A to B, but like, you know, you can flip part of the traffic onto one side as you're doing these application migration because you're using that sort of agnostic underlying event store. Yeah, so there's lots of really cool things about event sourcing. I mean, I definitely think that's true. But there's definitely also some bits that made me a little bit more hesitant working in, like, getting started with event sourcing, and I had a little bit of resistance, like a couple of different pain points. So one of the ones that I think was like most immediately obvious to me when I first started working with event sourcing is this pain of like seeing this like bigger is not always better. Like the system bloat is very, very real. And again, a lot of these things I mentioned, your pains, are definitely things that are fixable, and you definitely can work around them. This is not true for everyone. This is just some of the things that I have seen. But the cool thing is you can replay events since the beginning of time. The painful thing is then you have to support events since the beginning of time. And that can be very useful to sort of like maintain this information, and you can be dynamic about it, but then all of a sudden too you get like these like more and more different like classes, and it really sort of can bloat the code base as well to make it harder to read. And like as you guys know, if code is hard to read, then it's harder to write and harder to add to, harder to support. There's also like event versioning is a whole other beast, but when you do go and create new events and you version your system, you you know, the person writing it is looking at, okay, what does the previous event look like, and how is that going to change to this new event? but very rarely are you looking back like 3, 4, 5, 10 versions ago to make sure this is still being supported. So there are ways around this, like in terms of whether it be like black box testing or testing against older environments, which is really helpful and good. But it definitely has some risks and definitely is a place that you might get some like unexpected bugs if you're not careful about managing your previous versions. And then the other thing about being like growing in size is you can have lots of different projections. It's not just a single like one-to-one relationship. But then the more that you are projecting these different versions of your underlying data, and the more different people, engineers, teams who are looking at these different projections because they have different use cases, can also run the risk of having different interpretations of the same data. Because it's not like if they end up counting, I don't know how you would count differently, but imagine like, you're counting something differently or you're adding something together differently. You're calculating prices in not exactly the same way because you don't have like that final state. Definitely can run some risks there. Again, with testing is one way to sort of help balance this out. Either one thing we use sometimes is data reconciliations, especially using our data pipeline. So you're able to make sure that if you're projecting the same values in different places, that those values, when it gets the data pipeline, are being consistent. So yeah, again, there are workarounds for this, but it is definitely something that can be painful from time to time. The next one is a slower than a speeding bullet, which admittedly, like a speeding bullet is pretty fast. It's like not a very high bar, but event sourcing is designed to be like an eventually consistent system. And I just actually want to preface this pain with like, this isn't actually a major pain point for us because as you might have seen from that insurance diagram, this is not like an instantaneous like thing to do an insurance claim. So if it takes, like a second or two in order to like fully become consistent, that's really usually not a major problem for us in our environment and in our context. But I did want to mention it because it is something that like, depending on what you're trying to do, I mean, it can be fast, but it's not like by default going to be fast. So you can use, one thing you can use to get around that is snapshots. So snapshots is saving that projection. So rather than having to replay the events from the beginning of time up until now, you can save, so the most recent ones, you're only incrementing it by one event, which is great. But the other thing to keep in mind is the more snapshots that you have, the more places that you need to make sure your system is eventually consistent, can also slow like the overall system down. So it is a bit of a trade-off depending on where you need your speed. So one good example, one of my coworkers worked at a bank who was like built on event sourcing, and the whole system was funneled by Kafka, a big Kafka event hub, and that was a source of truth for everything. But he specifically worked on the cards team. And so in the cards team, you need to make a very quick transaction decision of whether or not you're going to allow this person to purchase that cup of coffee. And you can't necessarily take 2 seconds to do that. In fact, their team had like a limit of 100 milliseconds. And so what they had to do for their team is they had to kind of move away from the same event sourcing architecture that the entire rest of the company used in order to make it sort of a hybrid between event sourcing and relational databases in order to hit their speed targets. So it definitely can create more complexity and challenges if this is something that's a challenge for you. Doesn't mean you can't use it, but just definitely not maybe its strong suit. Yeah. And so the last pain is one that I feel quite a lot, is the complexity addiction. So event sourcing in some ways can be very simple, but there is also like a lot of flexibility of what you can do with it. And because of that, like it can also get quite complicated, mostly in the fact of it's quite different than a paradigm that a lot of people are used to doing. So we found when onboarding new people to the team, whether or not they're like, a new grad or like an experienced new joiner who just hasn't used event sourcing, or even some who have used event sourcing but done it a different way than we do it. There is definitely a higher learning curve than we would have for our other systems. And we like to call it sort of like an explanation tax. It doesn't mean that it's not worth doing, or that once it's explained that it's not valuable, but it definitely isn't, we've found at least, not as easy for people to pick up as some of the more like common software architecture designs. Yeah, so that in mind, if I haven't completely put you off the idea of event sourcing, which I hopefully not, it is actually pretty cool, despite some various pain points. I just wanted to sort of leave with a couple of thoughts of more specific things that we've learned from our experience of like, that is really good to do, that you should try and do earlier, and some of the things that hopefully maybe you can avoid, if you're lucky. So some of the good stuff that you want to embrace, do try it out for a specific challenge. So you don't need to have a completely event-driven architecture in order to get value out of event sourcing. If there is a specific use case, like even a part of a specific system that you think might benefit from event sourcing, it's very easy to sort of plug and play, try it out, and get a feel for like how it works for this challenge. You don't need to go like delete all your databases and start over for this. And the best part is if you do this and then you realize, oh my God, I hate event sourcing is the worst, all you have to do is then project your events onto like this classic schema you want to move to, and then it's fine. It's like it never even happened. So it's very easy to move into as well as away from, even if it's just for like a little thing. The next thing is to be generous with the context you save. So the context being like the context of the event, the information, the JSON blob. Again, depending on your requirements, but like we found that the, like very tiny additional memory requirements, they're not a huge cost. They're not a huge, they don't slow down the system majorly, but they can be so extremely helpful, whether it's in like, if you're manually looking at the event and debugging it, or if down the line you decide to build an additional feature and you want it to work using, like for your existing policies or your existing domain objects. There's very few times where I've gone like, we really didn't need to save that. Usually it's like, oh great, this is here. I'm so happy this is here. And now I can immediately build out this new feature, this new projection that makes use of this additional context that I had added in there. So also I really recommend some sort of black box testing, because it's very flexible in terms of how you're mutating the different events. You can change sort of what those schemas look like. It is very helpful to sort of have those end-to-end views of just like not so much, you also want to have the unit testing to making sure things are happening like as expected, but when you're using event sourcing, making sure that sort of the inputs the same inputs give you the expected output is really, really valuable, so that you're not too hampered by being flexible with the schema changes. It gives you that higher degree of confidence in order to make those changes. This is something one of my friends said, make sure you're protecting event land. So event land is like your event store, your event schema. I've had some people, especially like new joiners, who look at the event database and they're like, oh, actually I want to get all the events that are like of this type, that's some information that's held within the JSON. And so they try and write this like complex query using like JSON extract. It is not how you're supposed to use using event storing. Like if you want to do that, you can make a new projection, you can add that information like to another view, but you shouldn't be like building the event logic into the event land. Events are like, they should be kept safe. Have your little Batman dog keeping them safe, and like keep everyone else away from them. And then some of the downsides to avoid. this is a very small but like major pet peeve of mine of like creating partial events. So when you're creating events, sometimes in some part of our systems we'll have what I call partial events. So you're trying to do a thing, but that thing is made up of like 6 saved events. And it's, as my coworker described, trying to revert half a commit. So each event should be a real point in time. Like you could go back to that event and know the policy actually looked like this at that point. But when you have partial events, say you're adding in 3 pieces that are like what part of a final product, you can't actually stop in that middle ground. So you don't know where to go back to. You don't know what the last real state was. And this is, I understand it was built in order to help reduce the bloat, but it's really frustrating to not be able to know where the actual policy boundaries are and those domain boundaries. Beware of the deceptively simple write. So what I mean by this is like adding events is very easy. That is great. Please add events. But just because it's quite easy, you don't need to think too much about what you're adding in. You really, really need to think about how you're getting it out. Like those projections is where a lot of the power comes from, but it's also where lots of the complexity comes from. So these are the things like definitely want to make sure that you're thinking about and that you're being aware of how this is being used and that it's not being like abused. Don't try to do everything all at once. Again, there's a lot of different components to event sourcing, lots of different ways you could optimize it, but like I would highly recommend just starting simple and then adding stuff as you need it. Like the biggest thing is once you have the events, then you can do the rest, but you don't need to pre-optimize, like start with like 8 snapshots or things like that. Like that's really not necessary. And the last thing is to just be patient with people who are new to your system. I mean, I feel like this is general advice for like anyone, anywhere, for any system. But like, it is a really cool domain, and once you've been working in it for a while, you're like, yes, of course, this is just works like this. But just like a general reminder, whether it's for this or anything else, like to be patient with people as they're upskilling on this, as they're getting used to this different paradigm, this different way of like structuring the data and working with it. Yeah, I just think, yeah, it's good life lesson for everything, really. Yeah, so those are just some of the things to maybe like keep an eye out for. But yeah, so hopefully I haven't completely turned you off of event sourcing, but thank you for listening to my talk, and good luck in your future event sourcing adventures. Yeah.
All right. Thank you very much. We have time for a couple of questions, the Q&A session. Okay. First one is coming up. Why did you decide to go with a relational database as an event store instead of tools which are made for handling a large number of events like Event Store DB?
Yeah, that's a good question. To be honest, I don't think we are yet at the point for the things we're using it for that we need something like Event Store DB. If you're using it for like high volume, so like for instance, as an insurance company, we do have like thousands, millions of quotes that we use, but we don't use event sourcing for our quoting system. We use it for our policies. And I mean, hopefully eventually we'll have millions and millions of policies, but we don't have that volume yet. So we don't require those really like high volume requirements like Event Store DB. And so MySQL is simple. It does everything that we need it to do. And if you have like either a higher number of events need like special features, then that's great. Like I know people who use it and love it, but like, you know, you can start simple and see if you need it first, because it's really easy to just use MySQL and like get going.
Perfect. Thank you very much. We have time for one more question because we're almost out of time. Last question. If the changelog becomes too large, when do you start deleting events from the start of the event stream, presuming you have the state in snapshots?
Yeah. So generally speaking, we don't delete our events. I'm not sure, other people might at some point. And again, maybe we just haven't got to that point. But there are ways you can partition this out so that, say, you have events that you aren't actively using. So you can put it, as I mentioned, some systems use like event stores in like CSV and Parquet files as more of like handling larger data. And that's also a way that you can sort of put it into like less frequently accessed thing. Like, you know, not that expensive to put a bunch of CSVs into S3 if you're not going to be using them but still want to have all of your events. But in general, I'd be very hesitant to start deleting events because snapshots are good, but again, then you lose a lot of that flexibility of being able to replay it if something changes. Yeah.
Perfect. Thank you very much. A round of applause for Heather, please. Thank you so much for being here with us.